Well, good morning. I believe a lot of you saw a very good basketball game last night. Okay, yeah, a few people. Nudge your neighbor if they start to doze off. Or if you feel you stayed up too late watching the game, maybe those are the folks that are sitting in the back.
Kansas one, yeah. 4 points, I think.
But Sierra Space is off to a great start.
Big comeback in the second half, biggest ever.
I see the extroverts are laughing and smiling, and the introverts are saying, hey, stop talking, let's move this thing along. So we will do the latter. I'm Jesse Wilson. I'm the Navy Maritime Lead for Raytheon Intelligence and Space. And it is my privilege to, on behalf of Raytheon Technologies, tee up and get us started with this panel today. One of the benefits of Sierra Space is it's Old Home Week. And so I see a lot of former bosses, shipmates, friends, and we have some on the panel here as well. Matter of fact, Vice Admiral Khan and I were warfare commanders together in Nimitz Strike Group back in the day, and we've served together several times since. And it's always good to see him, and obviously Dave Johnson as well. E-Ring, Pentagon time, lots of battles there. Good to see you as well. This week, there'll be a lot of discussion regarding payloads and platforms. Now, Raytheon Technologies and a lot of you out there develop the payloads, the advanced payloads that will fight and win not only tonight, but in the future. But the platforms can come in all shapes and sizes, and they can be manned and unmanned. Our topic here today for this panel, unmanned advancements in warfighting. So just to get the juices flowing, I'm going to tee up and offer to you the 7 Ds of unmanned platforms. We added a few. What do unmanned platforms do? They do the dirty. They do the dangerous. They do the dull, the duration, the deceptive, the disruptive, and the distributed. And with that, I will turn it over to our moderator, Dr. Andrew Mara, the Executive Vice President for the Center of Naval Analysis. Andrew.
Thanks. Good morning, everybody. It's my pleasure to be the moderator for this panel on advancement in unmanned warfighting. As most of you in this room know, the Navy, and in fact DoD writ large, is pursuing unmanned systems in every domain: air, surface, subsurface, and those systems provide a number of capabilities that we'll be talking about today. It's a chance to increase the size of the force, to distribute the force, to provide new capabilities, new attack vectors to the force. But with those capabilities and that promise comes a series of risks and challenges. Those risks involve things like communications and logistics and training and infrastructure. So today our panel is going to go through both the promise of those systems and the challenges associated with transitioning them to new transformational warfighting capabilities. So with that, I'd like to introduce our panel. Vice Admiral Khan.
Hey, thank you, Andrew. Well, good morning, and it's a pleasure to join you today. I'm Vice Admiral Scott Khan, the Deputy Chief of Naval Operations for Warfighting Requirements and Capabilities. I'd like to thank the Navy League for having me join this esteemed panel today to discuss unmanned capabilities that the Navy is integrating into our future architecture and force structure. And the Navy continues to make advancements and investments in unmanned capabilities in support of strengthening maritime dominance. Now, since I spoke last year on this topic, we've stood up the Unmanned Task Force that is looking for a different way to solve the key operational problems that we are facing, to look across various domains: the air domain, the surface domain, the undersea domain, and the resource sponsors that make those investments, and give, instead of a vertical view, a horizontal view, and how we can accelerate capability and deliver it to the fleet with velocity. So if the numbered fleet exercises that we did in the past year, 5th Fleet and 6th Fleet, in both cases were some of the largest exercises that they've done in those areas of responsibilities where we put unmanned systems in those exercises with our industry partners, with our allies, to iterate, to learn, to understand the capabilities, the gaps that we need to close on before we make the decision to scale. And I'll say specific to the Fifth Fleet, the IMX, the International Maritime Exercise in 22 that completed in February. Again, it was one of the largest maritime exercises in the Middle East, with more than 80 unmanned platforms playing and more than 10 partner nations. That is the type of environment that we need to continue to resource and to use, because I'm a firm believer some of the really clear, innovative solutions is going to come from the fleet. Give them the tools. Let them iterate. Let them learn. Provide us in the Pentagon feedback and industry, again, before we make the decision to scale. And there's three themes that I'd like to stress here today. One is that we're taking an evolutionary approach to integrating unmanned systems into the Navy rather than revolutionary. Again, getting technology in the hands of the sailors, allow them to rapidly learn and quickly iterate before we scale. That said, we are looking for disruptive, revolutionary technology that we can fold into this plan. And through the process, getting engineers to work side by side with operators to accelerate that learning from the operator and engineering perspective, which I have found in other places to be key to moving with speed. And then working with industry to build a little, test a little, learn a lot. Again, that's part of the iteration piece. And then there's a discussion and a topic of artificial intelligence and machine learning. But I look as artificial intelligence, everybody talks it as if it's a noun, something very specific. I look to it as a verb. We need to drive action. We need to drive focus. We need to be more disciplined in describing what we need artificial intelligence to do. What machine learning do we actually need? How are those investments closing on our key operational problems? And how they're linked to our concept of operations in terms of how we're going to shoot, how we're going to maneuver, how we're going to resupply, and how we're going to defend in high-end conflict that could potentially be in the Pacific with the expanse of the Pacific in mind. So I look forward to the questions. That's just kind of maybe some tee-up, some follow-on questions. That's my kickoff.
Thanks, Admiral. Ken, you want to take us off now?
Sure. Thanks for having me here today. I'm Ken Plax. I'm the Deputy Director of the Strategic Technology Office at DARPA. DARPA's kind of got UAVs in our DNA across all the domains. Obviously, stuff in space that we've done over the years. The first satellite launches for the United States were actually done by DARPA. And there was a lot of autonomy because you couldn't reach out and touch them. We've done undersea vehicles. We've, like the Hunter, extra large UUV. We've done gliders with like Timely, which is a communications relay, totally autonomous for on the order of a year. We've done surface vessels. We've done land stuff. We've done underground stuff. We just recently had the underground challenge, subterranean challenge, where you were trying to navigate robots through an underground maze and find, dummies that were supposed to be, accident victims or miners or whatever. And that's actually a really good proxy for the modern battlefield, because underground, I can't really rely on GPS and I can't rely on communications, much like an A2AD environment. So that's actually a really good challenge problem. A lot of our autonomy tends to be the current state of the practice tends to be about GPS deep. Yeah, as soon as I lose GPS or comms, my ability to swarm and collaborate is pretty much gone. So we're investigating how to do that when you are in those denied environments. And then lastly, in the air, I'll just kind of a shout out to a couple of programs. The first being ACE, You might have saw about a year ago on the internet, we taught robots how to dogfight and then put an Air Force fighter pilot against him, and he lost like 5-0.
That really hurts.
That really hurt. And I used to fly F-16s, and you're just watching it, just going, "Oh, please stop!" And that poor guy's going to be buying beer for the rest of his life in every fighter bar, around the world. He was a good sport about it, and there were some artificialities in it, but the purpose of ACE, that was very photogenic and was on YouTube. The purpose of ACE is to figure out how to have manned and unmanned operating together and actually trust the robot. That's your wingman. I don't see us removing humans completely from the loop anytime soon, but I can see a future where it's human on the loop, where you're like, go take care of that threat and tell me when you're done, and it just does it. I could see that. Second program that I want to highlight, we talk about distributed and swarms. Launching and recovering 1,000 aircraft is actually really hard. If you go to Nellis for a red flag, there's about 30 or 40 airplanes, and it takes an hour just to get everybody marshaled and armed and off the runway. So how do you launch and control 1,000 aircrafts? We recently did a program called Offset that was recently in the news, which was about 100 drones, and it looked like the jukebox of the apocalypse. It would kind of throw these little quadcopters out. But even that really doesn't scale to the numbers we're talking about. But the command and control of all these vehicles is important. And the last one I want to talk about is something we did for the Army called Sesu, Small Unit Enhanced Survivability, I think it's what it stands for. We had a swarm of drones go out and find a mock-up out at Yuma of a, SA whatever. They autonomously divvied up the airspace, found the target, radioed home, and then we launched another drone, which was a Firejet for this instance, with an autonomous seeker. That was another program called Sector from DARPA. It navigated without GPS, basically using visual references on the ground, so kind of dead reckoning. Found the target, ID'd the target, did aim point selection, and then hit the target within a foot of its aim point, all autonomously with no humans involved. So that's coming, and part of DARPA's job is to kind of see what's coming. The very first UAVs, in conjunction with the Navy on a program that was called, I think, Teal Rain, was the first kind of medium UAV that became the Predator. Obviously, the Global Hawk was one of the first real autonomous UAVs. That also was a DARPA program. So to a certain extent, if you're not doing your job at DARPA. If people don't look at you like you're crazy, and if the services don't initially not want what you're offering, the Air Force with stealth aircraft being the canonical example. But I'm the technology guy. There's a lot coming. A lot of folks are going after some of the challenges the Admiral mentioned. It's an exciting time to be in UAVs. I'm glad to be here. Thanks for having me.
Thanks, Ken. And I think we can already see the interplay between kind of the operational impacts and the technology and the potential that provides. Dave, you want to introduce yourself and tell us how you see it from the industry point of view?
Absolutely. Thanks, Andrew. And it's great to be up here on the slide. Satan and I were partners in the building. Me as the acquirer, and he is the requirements side. I'm Dave Johnson. I've been with L3Harris as the VP of Strategy and working for Sean Stackley, my former boss in the Pentagon, as the VP for in the Integrated Mission Systems segment. Before that, I was 36 years in the Navy as an acquirer, mostly submarines. And my overarching point today is that we can accelerate unmanned. And if we can have the slides up, I can't tell if they're up or not. But we can accelerate unmanned in all domains to meet the CNO's vision, which is to be able to deploy unmanned vessels with strike groups and ARGs in 2027 or earlier. Okay, so next slide. As Vice Admiral Khan noted, there's been significant progress since last year's Sea Airspace in build and in exercises, developing ConOps, confidence in learning, the foundation for what's needed to increase pace. First, MUSV number 1, it's in construction at Swift Ships. It's an affordable platform for modular packages and rapid capability insertion in a fleet deployable asset. The land-based test facility will be delivered this summer to build the HM&E reliability confidence to meet congressional direction. And then in the center, in close concert with the UK's NavyX team, there have been continuous demonstrations of USV capability using their purpose-built small USV, MADFOX, a 41-foot MASS 13 vessel, which was used extensively in REPMIS last year, even fired a missile. On the right, the French-UK introduction of unmanned systems into the Maritime Mine Countermeasures, MMCM. It's progressing with both demonstrated Stage 1 capability and Stage 2 build. During sea trials in Stage 1, the MMCM prototype was tasked with detecting 140 mines over miles of open ocean in harsh sea conditions, which it successfully executed. And the turnover of SCO's medium USV surrogates, I was talking with Ken before, I consider DARPA the accelerant here, and this SCO project for the Ghost Overlord fleet is a great example. So those were turned over to the Navy after a successful capstone exercise last November with opportunity to demonstrate payloads, improve autonomy, and develop ConOps with a DevRun. And then the first successful launch and recovery of a small autonomous undersea vehicle from an underway fast attack submarine last year, with more testing this year leading to deployment. So it's not an exhaustive list, but there is a real progression of unmanned capability. Next slide. We are gaining trust with autonomy in ensuring these vessels, as the CNO stated, quote, deliver a platform that's going to be reliable and it's actually going to perform as intended. There have been several exercises where unmanned capabilities performed a variety of missions, building ConOps and user confidence in reliability and predictable performance, demonstrating real autonomy and manned-unmanned teaming, and proving interchangeability with our allies. A key exercise was IMEX 2022 with small USV-sized vessels like Al Sear's USV Scarab pictured. In the lower left is an excerpt of what was shown in the Royal Navy's Lyme Bay Command Center during IMEX. This exercise was a critical demonstrator of an evolutionary approach to learn, as Admiral Khan noted, in this case for maritime security, that provided revolutionary results for changing the way combined naval partners provide maritime security. And it offered a few things: adapting unmanned platform scale for meeting several missions, detecting, tracking, and intercept, all at lower cost to the customer. New effects chains for persistent ISR, C2 with multi-mission effectors and sensor platforms, and demonstrating military force protection and commercial applications. And demonstrating the value of sensor fusion and manned-unmanned teaming, with AI finding threats and alerting operators, which reduces the workload and improves performance. So looking forward in the lower right there, the continued work with small AUVs like Ivor 4 to fulfill critical undersea mission gaps, providing a bridge nav aid for manned platforms using the same autonomy that guides unmanned platforms, making manned vessels safer while increasing user adoption and improving the autonomy through machine learning. And then increasing exercise pace and scope. RIMPAC 2022 includes significant unmanned participation, and like IMEX, will be leveraged for rapid manned-unmanned teaming and learning. Last slide. Navy industry partnership. Industry needs return on investment for its IRAD. Industry invested to rapidly meet the Navy's needs. To keep the pace, a fast learning approach with evolutionary progress, it's happening now. In vessels, in autonomy, in payloads, and in ConOps. An integrated balance between platform, payload, and reliability development, it is possible and will result in deployable assets for CSG and SAG deployment before 2027. A specific enabler, as I've noted here, is a cohesive and a comprehensive payload development effort to rapidly advance capability and network integration. So in conclusion, the Navy and our international partners, we have an opportunity to move left and increase learning with fielded capability, maturing medium-sized vessels, HM&E and payloads, both surface and undersea medium, while rapidly fielding small AUVs and USVs to meet real-world missions and close existing capability gaps, and maturing the technology, the autonomy, drive, AI/ML, and working with the Navy and allies for effective ConOps and MUM-T. Without this acceleration, we will fall short of the CNO's intent and fall behind the very real mission needs that are today's problems. Thank you.
Thanks, Dave, for bringing us kind of up to speed on some of the exciting advancements we're seeing in both the systems, but also the payloads and some of the enablers that connect them together. With that, Jeff, turn it over to you for introductory remarks.
Thanks, Andrew. If you could bring up my slides. Thanks to the Navy League for putting this panel together. I think this is a really timely panel for discussion. I was struck yesterday listening to the Chief of Naval Operations and the Commandant of the Marine Corps both talk about how important it is to do the right prototyping, the right experimentation, the right demonstration with unmanned systems to meet the goals of the future Navy and Marine Corps. And you've heard Admiral Khan talk about how the Navy is getting after that and doing a lot of good work in demonstrating the capabilities that are available today. You've heard DARPA and my fellow industry partner here talk about the things that we're working on to continue to advance those capabilities. And as we do that, I think we need to keep in mind what we're really trying to accomplish for the platforms that are out there, the people that are out there. They have a lot of capability that we want to add to rather than replace or detract from. For example, we want to extend the reach of those platforms. The capabilities like the submarine-launched unmanned air system is a really great way to extend the reach of an undersea platform. The capabilities like a towed, reelable, active, passive sonar system that works on unmanned surface vehicles is a great way to extend the reach of DDGs, frigates that are trying to do ASW, trying to protect the homeland against potential deployers. And other capabilities that we need to continue to build trust in, putting weapons on unmanned surface vehicles to do the types of things that manned platforms can do under their guidance is important, and we need to continue to build that confidence, as Admiral Khan mentioned. And the way to do that is to continue with this campaign of prototyping and experimentation. So extending the reach, increasing the lethality, and enhancing the survivability of our people and our existing platforms are the things that we're focused on at Elbit America. I work for Elbit America as the Vice President of the Maritime Business, and we're really excited to be part of the community of industry and government working on these unmanned systems to keep our advantages over our adversaries in the future. I look forward to the panel, and I look forward to answering the questions. Thanks.
Awesome. Thanks, Jeff. So I think what we've heard across all of these kind of introductory remarks is the idea that there's a lot of progress moving forward in terms of both the platforms, but also the capabilities and the concepts that go along with them. So Admiral Khan, I'd like to turn to you and kind of ask, where do you see the most potential in the near term? And what are those kind of platform systems, capabilities, enablers that you think have the most near-term potential?
Yeah, and just to piggyback, I think, on Dave and Jeff's comments, if I had a slide to show to kick this off, it would have just been a bunch of ones and zeros. All right, because it's really, after visiting places in academia, Carnegie Mellon's, Johns Hopkins, and the robot development that each of those academic institutions are leaning into, and you go there and boy, there's some young, bright engineers out there that just gives me energy. But we have to get the software right in delivering artificial intelligence, in delivering the level of autonomy we need based on the conditions in the environment that we're trying to place these unmanned platforms. Trust was mentioned. I completely agree. Part of this is culture. As a fighter pilot, when I looked over in combat spread at my wingman, I had to be able to trust that human being to do the things that I need to do if I was leading him around. He needed to be able to trust me as his flight lead. So there is a trust piece. And again, you develop trust through iteration by getting it in the fleet hands, into the operators as we develop this trust. And as well, I think Sino talked about, various fit-up cycles, whether it be from 28 to 32 being a transition time, and then 33 to 37 being about force design and realizing this hybrid force. What we can't allow us to do is set ourselves up for concurrency and trying to develop this software and building robots at the same time. And we just need to be leaning forward in that. But to answer your question, number one, as a Navy, we operate in a multi-domain, in some cases, from the seabed to space. And that is the environment that we're going to have to fight in. I see the greatest potential in the development of that artificial intelligence that performs functions and tasks that we need it to do in a highly contested environment. We need to look for means to reduce the cognitive burden on our decision makers and our operators. We need to provide force multipliers to the combatant commanders at an affordable level. We need to increase our operational reach. We need to be able to conduct the long-range fires that we need to do. We need to serve, some of these unmanned systems must serve as a means to deny, deceive, delay our adversary, posing operational dilemmas on them from multi-domain. And then enhance our ability to sense, make sense, and act. All that is tied back to my comments about these capabilities must enhance our ability in terms of how we think we're going to fight in our concept of operations, distributed maritime operations, littoral operations in a contested environment, expeditionary air basing operations. That, when you look at the expanse of the Pacific, is our concept of operations that we'll continue to refine. But some of these unmanned capabilities must make it real. And in the process, we have to be intellectually honest with each other in terms of the level of autonomy that we can produce, understanding what the artificial intelligence will or will not do in that time horizon. And I think probably one of the more important capabilities specifically is the MQ-25. We are going to learn. That aircraft will get out there and will serve as a tanker. And in the process, we're going to have to make sure that the aviators trust that tanker will be where it's supposed to be with the fuel available and being able to pass gas. We've demonstrated a capability with an F-35. We've demonstrated a capability with an E-2D. We've demonstrated the capability that would pass gas to a Super Hornet. We're going to have to continue to lean forward and ensure that that capability is going to deliver what we need and enhance the operational reach of Airwing. And I have complete confidence that we are going to do it. Again, this will be an evolutionary approach, vice revolutionary, but we must be looking for those disruptive, revolutionary technologies that we can fold into our future.
Thanks, Admiral. Anyone want to add to the Admiral's view of where the Navy needs to head?
Go ahead, Ken. I know you have something to say. Nothing? I think when you look at things that can make a difference now, I'll point to the work that's being done with the submarine force right now to get an autonomous undersea vehicle in and out of a submarine with, I'll say, low overhead. It won't displace a torpedo, so you don't have to reduce your warfighting potential, but instead you can extend the reach of the submarine. It's been a long-term goal of the submarine force to use UUVs for that. So as we work with the submarine force, doing a progression from land-based testing, underway barges, and then work with the submarine force to do underway, first in the surface, then we did it at depth, we're learning. And through this summer, we'll have a capability by the end of this year that'll be a deployable asset and will allow not just the U.S. submarine force, but in fact, it's really an AUKUS effort to help this UK. It's called Project Scylla, and then what the Australian Navy's doing off their Collins-class submarine. So you can very rapidly scale work in the U.S. across 3 navies, and that is a very good example of moving warfighting capability, as Admiral Khan says, now, and it's being developed and learned by the fleet, the operator, where we're helping drive that forward. And the only other thing I'll note is in what we can do today with the small, and the IMEX is a good example. of being able to use the operators. We manned with the team there on the line bay, but to be able to have the feedback and then be able to use that with a fused capability and driving into, okay, what really does make a difference? For part of the exercise, the Scarab was 8 miles off the line bay, stayed out there 24 hours, one operator on the loop, monitoring it. The boat knew what to do, goes 42 knots. So if someone comes up to threaten it, it gets out of the way. Those are the kind of things that are fast learning. And then we can give Admiral Cooper no kidding capability as his PCMs have paid out. Every time we talk to the combat commanders, it's now. I'm sure Admiral Khan feels it, industry feels it. We're just not moving fast enough. But I think those are two pretty good examples of how we can go fast and drive the learning in the software development that Admiral Khan's talking about. Do you have the network right? And then what does that really contribute to closing kill chain gaps and helping relieve the burden on the warfighter? All those things, real time, you can make a difference today.
I would piggyback on what Dave said in that, number one, the networks matter. And the work that the Navy is doing with Project Overmatch will be complement the JADC2 effort. How we're moving the ones and zeros around at the task force level, numbered fleet level and below, is going to be critical to understand the resiliency that we need. And as well, because my job is multi-domain, I'm looking for some of these solutions that I can scale across domains.
Mm-hmm.
And we need to have that sight picture as well.
A couple things to add there. One in the evolutionary sense, as Admiral Khan said, and one in the more revolutionary sense. Combat logistics. MQ-25 is a great example of combat logistics, but there's a lot of other fertile ground that we can hoe in the combat logistics area with unmanned systems. And so getting after that in an evolutionary way and testing that out, which is beginning now, is a great example of the type of things that unmanned systems can do probably better than some of our manned systems, and missions that they should take on. In the revolutionary sense, I think we need to do more prototyping and experimentation, to Admiral Khan's point about multi-domain, simultaneously operating unmanned systems in multi-domains to accomplish very specific missions. I think there's a lot, as we develop the autonomy and as we develop the artificial intelligence, there's a lot that these systems operating in their specific domains can accomplish when they work together rather than trying to work independently. So those are two areas that I think are ripe for more prototyping and experimentation.
Yeah, and I'd piggyback, and the importance of our various labs, both within the military, within academia, and within industry, is having these hardware in the loop, being able to iterate in massive numbers in some of these labs to prove out some of these artificial intelligence, and then getting into the real world. The importance of our land-based testing site, particularly for some of our unmanned surface vessels, making sure the whole mechanical and engineering aspects are given the reliability that we need, and proving that on land, under load, that it's going to perform to the expectations that we have set. And that also must be part of this discussion.
I appreciate that. And so I'm going to call a little bit of an audible here based on this discussion, which I think we've mentioned at least a few times, some of those supporting factors, be they communications, AI, PNT, that are required for unmanned systems. So Dave, I'm just curious from your perspective, do you think our current systems will be able to support those demands? And what are the trade-offs we're going to see here between autonomy and communications as we go forward?
I think when you look at comms and PNT, we need to do better in both. I'll start with comms. Resilient, secure communications with the unmanned platform is a necessity, and it has to be built in from the very beginning in your architecture. It's important as these assets are over the horizon and out of view that you have a continuity of the SA of what's going on with that asset and then what it's feeding back to the operational picture. But given that, if in fact you do lose communications, you have to have I'll say the mission command into the autonomy so that the autonomous vessel behaves predictably, stays safe, and can keep doing the mission even when it's disconnected from the network. There is a level of autonomous maturity that you need to be able to function out there. I think that's one of the reasons why doing things like IMX so so helpful at getting confidence in the user, but also industry learning and then making changes that go into that. When you start looking at things like PNT, as Ken noted, you lose GPS, it's pretty hard. On the surface, there's ways you can get around it, even things as old school as celestial, but you can use with precision timing, you can use triangulation and fixes off of landmarks and other RF emitters to do some of the ability to continue doing the PNT kind of functions. Undersea, there's technologies, bottom, interacting with potentially a seabed system that's there, that you can do it. But are those things ubiquitous and were practiced and they work today in a denied environment? No. Those are all things that we need to work on.
Yeah, Ken, I know DARPA's taken a look at this problem of how you handle this, particularly for large numbers of unmanned systems. Any thoughts?
Well, in a denied environment, you really can't plan on there being PNT, and you really can't plan on having comm when you want it. You may get comm at times, but it's going to be bursty at best, according to most folks. But it's interesting, one of the things we're looking at, and I don't have the answer to this yet, but if you watch a pack of wolves hunt, they're not talking to each other, but they're working as a team. And the science behind this is something called theory of mind, right? So if I'm teaming with you, Dave, I kind of in my brain know what you're going to do under a given set of circumstances, and I can project what you're going to do and what I'm going to do. So autonomy tends to not be good at this currently. It tends to be every man for himself, or every robot for himself. And so, they'll each robot wolf would chase its own deer, and they don't work as a team. We've actually done experiments where we've taught them to think about what their partner's going to do, given the data that they can see and what they think their partner sees. And then you get this emergent behavior like a wolf pack where they focus on one deer, and even if the deer is faster, 3 wolves track it down and get it. And I think you can do that as well with autonomous systems. There's this interesting, almost like a Tao of, the more autonomy you have and the better your autonomy, the less you need to communicate, and vice versa. And so trying to strike that balance, I think, is what's going to be a fruitful area of research in the future to try to get at this. The other things, again, not going to probably be by the 28 timeframe, but we are looking at a whole host of non-IP based, non-MANA network topologies, trying to get at the communications. It turns out when you have the normal, if everybody sees the lightning bolt charts that they love to make at the Pentagon with everybody talking to everybody, about half your network traffic is just motherhood of trying to keep track of whose turn it is to talk, and yeah, I'm still here, and all of that. If you can get away from some of this mesh networking and focus on prioritizing the communications that have to happen, there may be an opportunity to, when you do get that little window where you can talk, actually send the message that needs to get through at that time. So we're working through all of those things. Stay tuned.
Andrew, I just note that the good thing is this is the exact same problem that the manned component has to solve.
Yeah.
So the unmanned thing is just another node that's plugging in, but you need this for essentially joint all-domain command and control capability. If you can't communicate, it's a bit of a fallacy. So you really do need that.
And there's an element of the trust and confidence between the autonomy and the communications as well, right? As we build more confidence in the autonomy and the automatic target recognition in the things that unmanned systems can do for us, then we'll have less reliance on the communications. And a simple example, this morning I got up and I was going to go for a run, and so I checked my weather app. And I've gotten to the point where I trust that weather app to tell me to the minute when the rain is going to start. And it said it was going to start in 4 minutes. And I said, well, I'm going to the treadmill. So in the beginning, those weather apps were not very good. I live in San Diego. I was living in San Diego at the time. And 90% of the time, it was not telling me what was really happening with the weather. But over time, over the past 8 to 10 years, it's very precise now, and I trust it to tell me what's happening. So those are the kinds of things that will happen as we continue to experiment and continue to demonstrate capability.
I'd like to just dovetail a little bit off of that, in that if you reduce the workload of what has to go back to the command center, so the tactical edge node processing capability, the local cloud, and the ability to do, as you're saying, basically do the smart AI, ML enabled information and the sorting and the triaging, then you can feed back a much lower bandwidth back to the COP with processed data instead of raw data. I mean, that's really where it gets to, Admiral Khan says, you would like the unmanned thing out there to send back intelligent information, not just raw video streams or raw data. And that capability is definitely, it definitely exists. One of the things I think industry can bring to the customer there is we work with people like Amazon Web Services or Anduril to try to take best of breed technology that the other services are using and put it in, exercise with it, and then scale it into the customer's problem set as fast as possible. I think that's one of the roles of you should expect of the A&D business, and that's something that actually, L3 Harris, we're a trusted disruptor. This is why we think that this is how we can move fast and meet Admiral Khan's demand signal.
Just the only thing to add here, and just to amplify, there are challenges that we have with the level of autonomy we're looking for, how to operate in denied, contested type environments. But the potential solutions, and in some cases solutions that are already in development, are very hard to talk about in an unclassified form. We are not admiring this problem. There are people that are delivering potential options, delivering capability to be able to mitigate some of those conversations. And that's about as far as I can go.
Appreciate that. Ken, I want to dive a little deeper on your kind of wolf pack example, which is, in nature, you've got 2 dozen wolves that might be working together. If you scale that to 100 or 1,000 wolves, it's a pretty scary picture for your adversary, but it's also a scary picture for the operator, right? How do I get 1,000 wolves to all operate in unison? Any thoughts on how we kind of impose that complexity on our adversaries, but simplify it for our operators?
Okay. Well, this kind of rhymes with JADC2 in that, if everybody's probably been to a little kid soccer game and, it's everybody's chasing the ball, right? It's like this amoeba chasing.
Group of individuals vice a team.
Yeah.
Yeah.
And autonomy does that. Actually, the services do that too. So, the joke at DARPA is everybody's got service all domain C2. The Navy might throw, an Army unit in, the Air Force might throw a boat in. So service all domain C2 or SAD C2 is kind of the things that we're currently doing. We're trying to get better. To kind of break this problem down, I kind of talked about knowing what the other folks are doing. From a command and control perspective, it seems to be that it needs to be hierarchical. So for instance, if I'm conducting a kill chain, someone's got to find the target and track it. Someone's got to engage the target. Someone needs to make the decision to do those things. And if, we're in some future conflict, let's say we're in Ukraine, right? And I've got an F-18 that can hit a target. I've got an Army artillery unit that could hit a target. And maybe I've got an Air Force, hypersonic missile that could hit a target. And they can all do it. How do I pick which one does it, right? You could either have the little kid soccer thing where all 3 people hit it, which is inefficient and can add extra collateral damage. And then if you're at a high-end fight, like say on the other side of the continent over in China, there's probably more targets than weapons. So you have a magazine issue. Hopefully we'll never have to fight the Chinese, but the other option you can have is kind of the 2-man beach volleyball, where I thought you were getting it, he thought I was getting it, and it goes right down the middle, right? And nobody gets it. Or we react too late and we miss the target. So sorting through that, a way you can do it, we've been doing this, and this is actually transitioning to the services in piece parts, is this hierarchical, almost like Amazon. When you go to Amazon to buy a pair of socks, there are bidders, and they're throwing out, here's the socks I have, this is the price, this is the delivery time. Amazon has an algorithm that ranks the 2 million people trying to sell you a pair of Argyle socks and matches them up and gives you some options. And then you pick an option, and then Amazon actually goes out, talks to those, his little agents actually running around, and so this is, again, more AI pixie dust. The agents go, yeah, I can deliver those socks at this price, or no, I'm out of inventory. So if you've ever clicked on a link and it says, oh, I'm sorry, I can't do that, what actually happened was Amazon, in order to present you with rapid options, was using somewhat stale data. And when they freshened the data up, the world had changed. And so you pick another set of socks. We're actually doing that with command and control. Warfighting a little bit more difficult than buying socks, but the ideas of hierarchy, and when I say, okay, I want this F-18 to hit that target, there's a whole nother level that needs to happen next of, well, he's going to need gas, because now he's going to be below bingo fuel, so he's going to need to get more gas on the way back. We need a tanker to be in the right position. You don't want to make that decision at the very top, right? Because you don't have all the insight. So each layer of the hierarchy, working its way down into bite-sized problems, is, I think, a way of managing that complexity. And we're demonstrating that. Conversely, by having 1,000 different things that can hit a target as a defender, what do you defend against? If you try to defend all of them, you're going to spend all your resources on the first volley and have nothing left. So that is a way of imposing complexity and kind of a death of 1,000 cuts type of a scenario upon the nation's adversaries.
The only thing I'd add is I'm all in on imposing overwhelming complexity on our adversaries. But to be perfectly clear, I have a firm belief that we must. I'm going to repeat that. I have a firm belief that we must drive simplicity down to the tactical edge. I've seen complex systems and tried to employ a few that may involve a series of consecutive miracles. I'm not looking for those type of solutions. We owe those warfighters on those ships, in those aircraft, in those submarines. We need to drive out the complexity.
Absolutely.
So I would push back on your comment that we're going to accept a higher level of complexity. Quite the opposite. We need to drive to simplicity.
Yeah, I think one of the things that AI is good at is kind of handling, the dull and whatever else. I forget what the 7 Ds he said. But with the hierarchies I was talking about, it gets it down to a human-sized chunk.
Right.
And it's very similar to, the whole commander's intent and centralized decisions and decentralized execution. It's very consistent with military thought. It's just folks forget all that when they go into cyberspace for some reason.
So I want to make sure we save some time for audience questions. So if you've got audience questions, by all means, start thinking about them, and then you can approach the microphones. But I'd like to pose one last question to the panel. And Jeff, I'll turn this to you. Obviously, we're not going to be fighting by ourselves. We will fight with our allies and partners. How do you see we leverage those capabilities as we think about our plans for unmanned systems?
Yeah, I appreciate that question. I think there's a lot of great work that are going on with our allies and partners, and both in conjunction and exercises that the U.S. is participating in, and independently in efforts that they are doing to get after the unmanned advancements and warfighting problem. So I think the exercises that Admiral Khan talked about earlier are extremely important, because we're able to see what our allies are doing, interoperate with how our allies are employing unmanned systems. And I think we also can learn from their employment of those unmanned systems and the sensors and the integration that they have done And we can take specific examples of that and bring it back into the U.S. and industry can help with that with our international partners, bringing some technologies into the U.S. And deploying them onto our unmanned systems. If basically we don't want to reinvent the wheel. If our allies have solved a particular problem about how to integrate a great sonar on an unmanned surface vehicle, for example, we should take advantage of that and not try to redo it ourselves. So there's a lot of opportunity, and I think the exercises with our allies and partners are the vehicle which will help us accomplish that.
Andrew, I'd like to add, I think there's great opportunity to use the international work we're doing to accelerate capability back to the Navy, and I'll highlight the Royal Navy's Navy X team. They had the vision to acquire a MASS 13 back in 2019 with Distal, so the Defense Science and Technology Lab, and then it was delivered to the Royal Navy in 21, and every week they've been going out exercising with the Mad Fox. The U.S. Navy directly benefited for that because all that knowledge and learning was what was in Scarab that was used in IMEX in Task Force 59's exercise. So if you do it right, you can use the international partners' innovation and the work they're doing, and then bring that technology back across to the U.S. and then scale it to other allies. That was just one good example of getting a real discriminating tech, advancing learning, operator input, and then pulling it back into the U.S.
All right, if you've got a question from the audience, by all means, feel free to approach the microphone, and we'll take audience questions from here.
Good morning, gentlemen. My name is Rob Westdorp. I work for TNO in the Netherlands, so one of the partners, so to speak. The question I have is, I hear a lot about autonomy. The platforms are getting bigger, and somewhere on the horizon will be an actual warship that's autonomous. Now, the question I have is, aside from being a fighter needs to be able to give away a blow, a punch, but it needs to be able to take one as well. So I wonder how damage control and ship survivability is in the autonomous plans.
I'll take part of the, I think Jesse kicked it off, the dull, the dirty, the dangerous. The first thing I wouldn't push back, but I would say we have to recognize that we are going to ask our sailors to do dangerous things. That's number one. So we're not going to remove that danger. We're trying to reduce the danger. You mentioned we're buying large things, and in some cases that is true, but we also must go after the affordable, the plentiful, the attritable. And that is from an affordability aspect. And those affordable, plentiful, how do I get them into the expanse of the Pacific? And that may be drones on drones type of solutions. Are drones coming from our submarine force that has some advantages, significant advantages in the undersea domain? I don't think we can try to solve all things. If we try to, we have to acknowledge that if we're going to put these unmanned things forward in an environment where ordnance is flying two ways, from us and at us. There may be a terminal defense question, other ways to solve terminal defense missions with something other than a metal-on-metal solution. I think we have to get real about that. In a high-end fight, things are going to get hit. And if we try to have everything be so survivable, we are going to be a much smaller Navy. We're going to have to accept some risk. We just need to be eyes wide open in defining that risk in lines with the return on investments that we're making to these platforms and programs. That may not be the answer you want, but that's the answer that I gave.
I'd like to piggyback on that. I think that's an excellent answer, right? I think we really need to put some thought and some experimentation into the attritable nature of small systems and what they can do in sacrificing themselves for the Navy, for the Joint Force. And having those small attritable systems come from the undersea is a perfect example of what they can do. If you have a small unmanned air system that has a very good sensor and a very good automatic target recognition capability, as well as an ability to communicate that to either the platforms that might be shooting long-range weapons or the long-range weapons themselves, then you have a really disruptive capability that is within reach, right? That we can go and actually demonstrate today. In fact, that is exactly what Elbit America is planning to demonstrate in September. So these kinds of capabilities are possible, and we need to do more of them, leveraging the small and attritable vehicles that are really optimally designed for those really dangerous missions.
So one of the things that sometimes gets lost on these discussions is the application of operational art in the use of this technology. Our concept of operations, a multi-domain view, giving combatant commanders capability that they can apply from a multi-domain approach within an operational art construct, playing to our strengths, attacking the weaknesses of an opponent. I mean, this is a complex discussion. I mean, the science is the science, but we can't lose sight of the impact of operational art and how we use these technologies.
That's great. I'll take a question over here on the right.
Yeah, good morning. Thank you. I'm Ken Perry. I work for Thayer Mahan. I'd like to try to tie a couple of things together. I think, Jeff, you mentioned trust and others mentioned trust in systems. I'd like to talk about not so much the systems, but the employment of the systems. And I'd like to focus on the sense and make sense part of the spectrum, not the lethality portion. And I'd like to address my question to Admiral Khan as a fleet commander and operator. If you see, sir, the potential or the way to leverage those types of systems through a contractor operated model to help simplify things for the warfighter. They get the awareness, the data, the sense making, if you will, without all the friction of deploying the system, sustaining them, et cetera. Where do you see that as a viable option for employing the systems?
I think if I understand your question correctly, there were contractor-owned, contractor-operated capabilities that were part of IMX, which I am most familiar with. They may have been participating in the REPMUS and 6th Fleet. I see that as a means to go fast. The next question would be, okay, how about in conflict? So, I mean, we have to complete the sentence and understanding, okay, is this to be able to iterate and learn before we scale? In some cases, having a contractor-owned, contractor-operated model. I typically like not to have these conversations with my wingman, Admiral Morley, who's in the acquire side, so that you get both points of view. Am I answering your question?
Yeah, I guess I need to be a little more specific. If we talk about
Bring it.
long endurance systems that are distributed as you described, they're out forward, they're attritable, they're affordable. You lose them, that's kind of cost of doing business. Whether that might lend itself to a contractor operator model, those systems would be delivering you the awareness wherever you want it. You don't have to operate them. Whether that would give you a sort of this complementary, enhance your exquisite manned platform capability, extend their reach, et cetera, without you having to bother with the nuts and bolts of maintaining all these distributed systems.
I would answer it this way. Everything is on the table.
Great. Thank you.
You're welcome.
Great.
Yes, good morning. Cleveland Easton with OpNav. One of the biggest challenges for defense is cost, and just trying to find out from our industry partners what learning can we get from these unmanned systems that might help us to reduce our operational costs of our manned systems?
I'll start. Use them. You need to get them out there and use them. The only way you're going to really learn about the husbanding cost of unmanned is to have them out there forward deployed and the fleet supporting them, and you understand all the illities that go with that. I know that from talking with Congress, their view is they're very concerned as the Navy thought through how you support these unmanned capabilities forward. And so I think that's part of the homework as industry and working with the Navy is that we have to bring a complete solution. When we deliver an IVR, we don't deliver an IVR UUV, we deliver transit cases of spares, training, and all the logistics so that you have a available capability, not just a thing, forward. You can scale that to what you would need to support an unmanned surface vessel or an unmanned aerial vehicle. Same kind of thinking. And I think the way you learn, as you're asking, is you need to get it out there and learn.
I would say, or to add, some of the approaches we're taking on unmanned are also applied to our manned systems, these land-based engineering sites for hull mechanical and engineering. That's going to be applicable to, or is applicable to DDGX. That is applicable to frigate. Some of the comments I made about hardware in the loop testing for our various weapons systems or weapons components. That's both in our manned systems and our unmanned systems. To drive out risk, to identify risk, to remove risk at velocity, because with enough time and money, we can do just about anything as a nation. We're running out of both.
To even take that a step further, digital twins, modeling and simulation, live virtual constructive, those are all ways to get at that learning faster and cheaper that are being employed, right, and should continue to be employed both for manned and unmanned systems.
Great. Well, I think that was an excellent place to kind of bring our conversation to a close. I'd like to thank all of our panelists for an excellent conversation today.
Thanks,
with that,
Andrew.
appreciate everyone coming by.
Thank you.